In this video, I'd like to talk about solving exponential equations using logarithms. And in a previous video, we talked about solving these types of equations using exponent properties. For instance, we might have had 8 to the 2x minus 3 is equal to 64 to the 5x. And we could rewrite 8 and 64 with a common base. Namely, 64 is really just 8 squared, or we could even use 2 since 8 is really 2 to the third power, and 64 is 2 to the sixth power. But in these problems, we won't be able to use exponent properties since we won't be able to rewrite these with the same base. So we need a different strategy. So let's rewrite the problem first. We have minus 3 times 10 to the 2t is equal to minus 28. Now, the general idea with these is that we want to solve it for the exponential expression. Once we solve it for that, then we can rewrite this as a logarithm and solve it for t. So let's first solve it for this 10 to the 2t, that's our exponential expression. So we'll divide each side by negative 3. So we have 10 to the 2t is equal to minus 28 over minus 3. The negatives will cancel, and we'll just leave it as a fraction. And now at this point, now that we've solved it for the exponential term, we can rewrite this as a logarithm. And to understand that, let's look at a simpler example. Let's say we have 2 to the x equals 8. And this can be rewritten as a logarithm where we have log base 2. The base of the logarithm is always the same as the base of our exponential expression. And logarithms are equal to exponents, or logarithms are exponents. So this logarithm is going to be equal to x, and then whatever your exponential expression is equal to, that goes on the inside of your logarithm. And in both cases, you can see that x would be 3 here. But the main idea is we want to practice going from an exponential expression or equation to a logarithmic equation. And we can look at this more generally as well. Let's say we have log base a of b is equal to c. So to rewrite this as an exponential expression, the base is the same, so be a, and we're going to raise it to the c power since the logarithm is equal to the exponent. And then whatever is inside the logarithm is what your exponential expression is equal to. So this right here is the key part of solving these types of equations. So we're at the stage where we can rewrite this as a logarithm. We're basically down here and we want to change it to some type of logarithm. So this is equal to log base 10, since the base of the logarithm and the base of the exponential expression are equal. And remember that logarithms are equal to exponents. So this equation will be equal to 2t, and the 28 over 3 will go on the inside of the logarithm. And I do recommend keeping this as a simplified fraction. If you change it to a decimal, then you're going to end up rounding a little bit in some cases. And from here, we can solve it for t. So notice that we essentially got t out of the exponent. And so let's divide everything by 2, or effectively we'll be just multiplying each side by a half. So we have 1/2 log base 10 of this 28 over 3. And log base 10 is what we call the common log. So you should have a button, if you have a graphing calculator, you should have a button that just says log, and that is logarithm base 10. So we actually can rewrite this as 1/2 log of 28 over 3. Now we can only do this where we write just log where the base is omitted here when the base is 10. Since this, like I mentioned, this is what we call the common log, since our whole number system is based off of 10. So at this point, now that we've solved this for our variable t, we can just put everything into the calculator. So let's get out a graphing calculator here. And we want to put in 1/2 or 0.5 multiplied by log. Here's our common log button. So we hit log of 28 divided by 3. And we should get some kind of decimal. So our answer here is going to be this 0.485 since we're going to go to the thousandth place. So we have 0.485, and that will be our final answer. Now, they also do want us to express this as a logarithm in base 10. So that's going to be this answer right here, our 1/2 log 28 over 3. So with this in mind, let's try some more example problems. The first three, including this one, we're going to look at when the base of the logarithm is either e or 10, since those actually have buttons on the calculator. For instance, a logarithm with base e, that's what we call the natural log. That's this ln button here. And like we mentioned, this is log base 10. Now, after that, we'll look at three problems where it could be any base. And for that, we'll need our change of base rule. But we'll get to those in a later video.